As Alan said, I used to work at the university in the physics department, teaching energy studies. I'm now doing a bit of climate change consulting for various countries in the Pacific. Papua New Guinea, Fiji, Vanuatu, Samoa. I do their carbon accounting for them at the national level for their reporting to the United Nations. I might also mention before I start that there's a big strike tomorrow, that when I was at the university back in 2011, I actually tried to get the university staff to go on strike. And I contacted the staff union, and they said, we'd love to go on strike, but if we did, the university might sue us. So we had to cancel the idea of a strike. Okay, so that's the introduction. I'm going to talk about climate change at the global level. You probably have all seen these numbers. They're all well known. This is the data from Mauna Loa. I downloaded this just this morning. The CO2 in the atmosphere is increasing. It's increasing. It's got that bumpy shape because of the northern hemisphere dominates, so it's a seasonal variation. But we're at around about in February, just a month ago, about 411, nearly 412 parts per million. Okay, that's just for CO2. If you add in the other gases, it becomes a bit more complicated, but we're over 450 parts per million with the other gases, but it depends upon how you add them. Okay, not only is the CO2 in the atmosphere increasing, but it's increasing at an increasing rate, so it's accelerating. Okay, so this is a graph of the annual increase in the CO2 per annum. And as you can see, back here, does that come up on the screen? Yes, it comes up on the screen. Back here it was around about, only about half a part per million, and now we're up to around about 2.5 parts per million per annum. So that means in 4 years, the total CO2 is going to go up by 10 parts per million. So we're at 410 parts per million now. In 10 years' time, we'll be up to around about 420 parts per million, and so on. Okay, so that's what's actually happening. That's the real data. This is not the carbon accounting you're going to be talking about a lot today, but this is what's actually happening in the atmosphere. We also know that the amount which ends up in the atmosphere is directly proportional to our anthropogenic emissions, how much we emit. And this is a graph showing the amount that stays in the atmosphere against how much we emit. And for every 1 tonne of CO2 we emit per annum, very close to 0.44 tonnes ends up in the atmosphere, a little under half. Okay, so there's a very strict relationship between the emissions and how much ends up in the atmosphere for CO2. The case for methane is a lot more complicated, and I'm not going to go into it today. There's a bit of a debate upon that. But it doesn't go up linearly. It's gone down and then up. Okay, so that's what's happened up there, and what's happened down here. Okay, the most recent IPCC, the International Panel for Climate Change report, the AR5 report, came out in 2014-2015. Okay, and they had various scenarios for the future. Now, it's very hard to read all those numbers on there, so I'm going to explain them. But essentially what they said is that they only found one scenario at that time called RCP 2.6, Representative Concentration Pathway 2.6, which kept us below 2 degrees. And to do that, they said that the whole world has to only use 905 gigatons of CO2, including FOLU, that's forestry and other land use, starting from 2010. Okay, so 900 gigaton from 2010. And that only gave us a 2 in 3 chance of actually staying below 2 degrees. So that's not very good. But we didn't start in 2010, and we've been emitting around about 40 gigatons per annum for the last 10 years. So if we multiply 10 by 40, we get 400. We take that away from the 900, And if we do a linear extrapolation to the future, then what it means is we would have to get down to zero in about 25 years from 2020. So we'd have to get to zero emissions by 45, sorry. The IPCC report thought that that was a bit drastic, so they actually allowed us to go out to 2070 before we get to zero emissions. But that included carbon capture and storage. That means we had to capture carbon from the atmosphere. And the IPCC scenario had us capturing CO2 from the atmosphere for nearly 230 years in the future. Okay, the latest report, which came out just at the end of last year in October, is the IPCC 1.5 paper. And this was put in because the island countries wanted 1.5 as the target, not 2. And again, you can't read that very well, but the main scenario here, which keeps us below 1.5 degrees, says that we can only emit 600 gigatons from 2018, which was last year. So if we do the same sort of extrapolation sum as we did before, the area of the triangle is 600. So we know the base emissions at the moment are around about 40 gigatons per annum, so we can calculate the time at which those emissions have to go to zero. And it comes out to be 30 years' time from 2018, which is 2048. The actual IPCC report rounded that to 2050. But really importantly, if you read the IPCC report carefully, their numbers, the ones that I just gave you, didn't include other gases, methane, nitrous oxide, etc., and didn't include feedback effects. They do note how much you have to reduce it by, and you have to reduce it by another 350 gigatons, which would mean we'd have to get to emissions to zero by 2030. Okay, so that's the IPCC. There's also lots of other papers coming out at the moment, and in particular there are the modelling community who model what the future is going to be, and the paleoscience people who look at what the past history of the Earth is. Jim Hansen, who some of you might have met here in Dunedin in 2011, he's put out a report called Global Warming in a Nutshell, and he said that we've already locked in 1.5 degrees with present emissions. So with 410 parts per million in the atmosphere, we have locked in 1.5 from a modelling point of view, and a whopping 3.5 from a paleoscience point of view. So that is a worry. So that's the global picture. There's a lot more to it, but I haven't got time to go into it. So what's New Zealand doing? New Zealand reports to the UN. Its 7th National Communication came out a couple of years ago, and it puts its emissions at around about 80 megatons. Okay, so nearly a factor of 1,000 smaller than the global emissions. And of those, about half are energy, a little bit more than half agriculture, and this lot here, Lulu Kafuk, is land use change, and forestry, which are the negative emissions which we get to account for by planting trees. The NatCom projections are that they'll stay flat for the near future out to about 2030. The net emissions will start increasing because the forestry, you can see it around Dunedin, all the trees are going out, they've all been cut down at the moment. So all the timber is moving along our highways and being exported overseas and causing these net emissions to come up here. The government, the present government, has said we have to get down to net zero by 2050. These are the various emissions. This is agriculture, this is IPPU, so this is the industrial use, this is transportation, and this is energy. So this is what has to happen. We've got to go here from 80 megatons in 2020-ish down to zero by 2050. We can offset some of them with some timber, but that's going to be difficult because at the moment the timber is going in the wrong direction in New Zealand. So that's the global picture. I'm now going to hand it over to Maria. We can look at the implications of this global picture in terms of fairness, uncertainty, immigration, third world issues and financial implications in the discussion section. But what we're going to do now is come down to Dunedin and look at what's going to happen there, and then we're going to proceed to see how we can fix this situation up. Thank you.